Let's create a sub-VI and then use it inside an application VI. For this demonstration, I want to create a sub-VI that generates a sinusoidal tone at a particular frequency. I'm going to use the sine wave generator as the heart of this sub-VI. Let's take a look at how this thing works. The main inputs of interest here are the number of samples to generate and then the frequency of the sinusoid. It's always a good idea to take a look at detailed help to make sure that you're interpreting that frequency input properly. In this particular VI, we see that the frequency is said to be normalized in terms of cycles per sample. Other signal generators in LabVIEW use hertz. You just need to check the help page on each one to make sure that you are using the correct form. I'm going to use a global variable to generate my sampling frequency. I need to change that to read mode. And then also the duration of the signal in seconds. You can always make a front panel control or a constant if you're not using a global variable like this. When I multiply those two together, I have samples per second times seconds. That gives me total number of samples. Now if I just connect these directly, I get my red coercion dot. It's always a good idea to take control over the type conversion yourself. In this case, the sub-VI is expecting a 32-bit integer for a number of samples. All right. That takes care of the total number of samples we need to generate. Let me place a numeric control for the oscillation frequency F0. I'm typing in F0 for that. This has value in hertz. Now, as we were looking at earlier for the help page, we need normalized frequency. We can get that by dividing the desired frequency in hertz by the sampling frequency, also in hertz. That's how we get normalized frequency. Can then connect that up to the frequency input. Now we have an array being generated by this sine wave generator. Let me create an array indicator on the front panel. I'll begin by placing the generic array, and then I need to drop in a control or an indicator to get the appropriate data type. Let me change that name to out. Then over here I will right click and change this to an indicator. Now before I continue, let's take a quick look at the output as a waveform graph and just make sure that it is in fact turning out the way we expect. This will ultimately not be part of the sub-VI, but it's just giving me a quick opportunity to test it. Looks like we generated a little over 2,000 samples. If I change the upper limit of my graph to some smaller value, yep, sure enough, there we see the sinusoidal signal. All right, we have the functionality that we need. Now the only thing remaining is to finish packaging this up as a sub-VI. Let's first get the icon taken care of. I'll delete the generic graphics here. And you can certainly take the time to put in your own graphics if you like. I'll just do the expedient thing here by typing in the name of the sub-VI. Note that you can change the font size. You can adjust whether or not the text is centered or aligned at the top. And you can also adjust the color of your text right here. So you have many, many options about how you go about creating the icon for your sub-VI. Next, we need to get the pattern selected and then connected to our inputs and outputs. We've got lots of patterns to choose from. This is the one that I'm interested in specifically. This allows me to generate an output which is centered on the icon, and then I would like my control to appear on the bottom. Let me go ahead and save this away, and I'll give this the name sign.vi. I'm going to take this opportunity to also point out that it's good practice to include the name of the subVI, or at least some kind of indicator about what the subVI is trying to do. And it's also common practice then, well, let me make this a little bit bigger first. I did Control-0 incidentally to bring up that dialog for changing the font size. It's also common practice to resize the panel to roughly the amount of real estate that's required by the front panel controls. And then you can press Control-I to bring up VI Properties dialog, select the window size, and then set the current panel size and hit OK. So that way when you open up the subVI, it has this relatively compact size. All right, let's go ahead and start up a new VI. This would represent the VI where you're calling the subVI. So I'll select that subVI and place it. Here we see our connection point for the oscillation frequency. Let me create a constant. It has a default value of 500. I'd also like to point out that that default value can be adjusted back here. You say make the current values default, and then you save the VI, or the subVI for that matter, and that default value is preserved. The output is being generated here. Now, supposing at some point you changed your mind, you can disconnect that terminal. You could actually disconnect all the terminals if you like, but you can disconnect one at a time, and then say reconnect the control point here. Save the file, and now we see the broken wire because the input has moved to the top of the subVI. And if you look carefully, you see that it's now appearing on the top. Now let me revert back to the original location. And I'd like to also illustrate that if, for example, you decide to change your mind about the pattern itself, again, let's go ahead and save that. Now is when you experience the subVI looking grayed out. Nothing would connect to it right now. To solve that, you right-click and hit Relink to subVI, and that discovers the new orientation of the inputs and outputs. Again, I'm going to revert back to my preferred layout here. Go ahead and save that. And again, since I've changed the pattern, I need to relink that. All right, that's some basics about subVIs.